In this video I'm going to have a go at using the HTS 2000 aluminium brazing rods to join a couple of bits of aluminium, and here they are, just small little bits. They're about 1/8 of an inch thick. The HTS 2000 material is supplied in the UK from this website, aluminiumrods.co.uk. I've got nothing to do with that particular company, I just found it on the internet so I thought I'd give it a crack. These are the rods here. They're about 2 or 3 mil in diameter, and roughly 40 centimetres long, there or thereabouts. The ability to join bits of aluminium is really useful in the workshop. You can do it by welding if you've got some fairly sophisticated skills and equipment. Can't really get away with gluing aluminium, that doesn't work. Normal solder doesn't work. Normal brazing rod doesn't work. So I've got high hopes for this stuff. Joining aluminium is something I've never been able to achieve, and it could be really useful. This is genuinely the first time I've tried to use this product, so I'm just going to give it a go and see how it works. These are the instructions that come with it. First job is to prepare the surface of the aluminium, and I'm going to use this little chap here, which is a stainless steel wire brush fitted to my Dremel. I reckon that'll do it. Quick run over by the wire brush. Pieces are going to be fitted together like this. I've managed to save most of my fingers, probably should be wearing gloves for that particular job, but never mind. So now I've brought over my portable brazing hearth, which consists of nothing more but a wooden tray with a few insulating bricks. I'm going to be using this standard plumber's burner, butane propane mix, and a burner on the top there. This should be more than enough to get this material up to the right heat. So I've used one of these bricks on top to weigh down the workpiece and hold it together. If this was an actual job I'd be doing something a little bit more sophisticated than this, at least I'd like to think I would. So the aim here as we heat the workpiece is to get it hot enough to melt the brazing material. We're not actually melting the aluminium itself. This isn't welding because we're not melting the parent material. I'm not sure whether it's brazing, strictly speaking, or whether it's soldering even, but anyway, the aim is to get the parent material hot enough so that when we touch the rod onto it, it will melt and flow into the joint, and then we'll leave it to cool down. Well, that happened quite a bit quicker than I was expecting. I'm just going to let that cool down, then I'm going to turn it round and have a look at the other side. So that's what it looks like on the other side. There's no evidence of the material flowing through the joint by capillary action, it's just stuck to the other side. So maybe what I'll do is I will reheat the work and apply more filler from this side. That was pretty easy. Not the neatest joint I've ever seen, but I'll just let that cool down and then we'll do a bit of strength testing. Doesn't look too bad actually, it's reasonably neat, not bad for a first attempt anyway. I was quite surprised how quickly I was able to heat up the aluminium to get the material to flow. What I can't tell is whether the solder has actually flowed into the gap, so what I'm going to do before I do any strength testing is cut this in half and see if I can see anything in the gap. So here we go, I've just set it up on my special bandsaw holding fixture and I'm going to cut it in half. So here's my two halves of the test piece. The one on the left I've just filed off to see if we can see whether there's a gap. In here it looks like there isn't a gap, but I wonder whether that's just because the soft aluminium's burred over and filled it. So I'm holding my first test piece in the vise and I'm going to use my trusty shifter to see whether I can tickle it a bit and see how strong it is. Probably not the best way to treat an adjustable spanner, but this one is pretty cheap anyway, so who cares? Right, there we go. So I'm putting a little bit of effort into this. Wow. That's quite impressive, I have to say. I wasn't expecting that, I was expecting it to break. So look at that, it's bent the original material, but the joint has held. I'm very impressed with that. Let's have another go. See if I can get it to break. There we go, it's gone. That's what the joint looks like. So the material has gone. Looks like a brittle fracture because you can see the crystalline structure there. Let's have a go at the other test piece. Here it is. Let's do the same thing with this one. See if we can get some fatigue stress going. Now there you go. That one actually broke quite easily. But it has still put a bend into the aluminium, so that's not too bad. I'm going to try a second experiment here. I've got 2 bits of aluminium again, and I'm going to make a butt joint like that. What I've done is file an angle on each one, like that, as if I was going to weld them together, so there's a bit of a V-shaped groove, and I'm going to try and fill that with the solder and see whether that makes a good joint. Get in there. It's probably just worth adding before this cools down, there's actually no flux involved in this process. Normally if you're brazing or soldering you'd be using a flux, but this stuff doesn't have any. I was also quite surprised at how quickly this heats up to melting temperature. It took less than a minute to do that job. So that's my joint finished, it's cooled down. There's no sign of penetration right through the crack at the bottom, but then again it was closed up tight, so that's not surprising. Looks like a reasonably neat joint. Let's give it a test in the vise. I'm going to start fairly slowly here, give it a bit of a wiggle. I'm putting a fair bit of force into this, but not a huge amount. I think I can see that joint bending already. There you go, it's gone. So there's the 2 halves of my joint. The solder's basically not stuck to this bit. There's some signs of it sticking, but it came away with just pretty light force, to be honest. If that was a proper welded joint, there's no way I would have been able to break that with just my bare hands, despite my immense strength. I'm going to do one final experiment in this trials phase. What I'm going to do is make another T-joint like this. I've put some effort into cleaning this surface with the stainless steel rotary tool, and I've just reread the instructions, and what I'm going to do this time is tin both of the surfaces first. So I've just made my joint and I'm now waiting for it to cool down. One thing I did this time, which I didn't do previously, was just to run over the joint with a stainless steel screwdriver as in the instructions. So here's my finished joint. Doesn't look too bad, it's a bit untidy. I'm putting quite a bit of force into that, in so much as my limited strength allows, and it's certainly holding. Let's get the spanner on it, tighten it up a bit. Yeah, I can actually feel the aluminium bending here. There we go, look at that. I'm quite impressed with that. That's obviously a very amateurish joint, and I've only been doing this for about 10 minutes, but that's a good strong joint that has held. In my opinion, I would not use this for any safety critical applications, at least not until I've got a lot more confident in making the joints and my own skills, but if you look at that, that's clearly held. It's got a lot of strength, this stuff, for general model making purposes or low stress applications. I'd be quite confident using this. So there we have it, my first experience of using HTS 2000 aluminium brazing rods. I'm pretty impressed. I'll certainly be continuing to use this stuff for my model making and model engineering activities in the future. So thank you for watching. Please remember to like this video, leave any comments down below, subscribe to the channel if you like it, and check out some of my other videos.